In this video, we're going to look at covalent bonding, which is a paper 1 and a paper 2 topic. We have seen bonding already. We've looked at ionic bonding. I'm just going to remind you of what ionic bonding is. So it's the bonding between a metal and a non-metal. And anytime we're talking about bonding and we're talking about chemical reactions, we're always interested in electrons. And we saw that metals will always lose electrons to get a full outer shell, and non-metals will gain electrons to get a full outer shell. So in ionic bonding, when a metal reacts with a non-metal, the metals will give their electrons to the non-metals so that the metals lose and the non-metals gain. So we can say that electrons are transferred. And this is easier using an example. So if I have sodium here, sodium is a metal, it's in group 1, so it's got 1 electron in its outer shell. To get a full outer shell, it will lose 1 electron. Chlorine's in group 7, has 7 electrons in its outer shell. To have a full outer shell, it will gain 1 electron. Sodium will transfer its electron to chlorine, giving sodium a full outer shell and chlorine a full outer shell. On the left-hand side, I'm calling sodium an atom, but when it loses an electron and gets a positive charge, I now call it an ion. Chlorine, similarly, an atom on the left, but when it gains electron, it's gaining a negative charge, and I'm now calling it an ion. So ionic bonding, you've got a metal and a non-metal, and the electrons are being transferred. Your actual definition of an electric bond is the electrostatic attraction between oppositely charged ions. Opposite charges attract. The attraction is called the electrostatic attraction, and it's a strong attraction holding those ions together. That's ionic bonding between a metal and a non-metal, but the focus of this video is on covalent bonding, which is between 2 non-metals. Now, as we've already seen above, non-metals want to gain electrons, so this is slightly less obvious than the ionic bonding. If I've got 2 non-metals and they both want to gain electrons, how are they both going to end up with a full outer shell? The answer is they are going to have to share their electrons. So in ionic bonding, we had electrons being transferred, but in covalent bonding, we've got electrons being shared. And again, this is easiest by using an example. So I'm going to stick with chlorine as my non-metal, and I've drawn 2 chlorine atoms side by side. Again, I'm calling them atoms because they've got all of their electrons. They both have 7 electrons in their outer shell. They both want to gain 1 electron to have a full outer shell. And the only way that this can happen for them both to gain is if they share. And when I draw the chlorine atoms sharing electrons, I need to draw the 2 chlorine outer shells overlapping. And this area that I've got in the center represents the electrons that are going to be shared. Now you need to know how many electrons chlorine is willing to share. We know it wants to gain 1 electron, and if it wants to gain 1 electron, then it is willing to share 1 electron. So chlorine's got 7 electrons in total. It will share 1, so I'm going to draw 1 cross in the center. But the other 6 electrons, chlorine is not going to share, and I draw them around the outside. Similarly, this chlorine atom has 7. It wants to gain 1, so it will share 1. It's sharing 1. I draw 1 dot in the center. The other 6 dots I'm drawing on the outside. A really common mistake is to draw an extra cross or draw an extra dot. Make sure you're only drawing 7 crosses in total, 6 on the outside, 1 in the center. And the dots, I've got 7 in total, 6 on the outside, 1 in the center. Each chlorine atom now has 2, 4, 6, 8 electrons, so each chlorine atom has got a full outer shell. I am still calling them atoms because they're sharing electrons. They haven't lost or gained, so they are not charged. They are sharing electrons. They are still called atoms. But I can call this whole thing, which is now Cl2, I've got 2 chlorines bonded together. This whole thing is called a Cl2 molecule. When you've got 2 atoms covalently bonded together like this, we call this whole thing a molecule. In terms of your definition of a covalent bond, you're not going to get any marks for saying the bond between a non-metal and a non-metal. You have to say a covalent bond is a shared pair of electrons. That's your definition for covalent bonds, and you get 2 marks for saying shared pair of electrons. And this here, this pair of electrons here, that would represent my covalent bond. Okay, so there's lots of examples of non-metals bonding with non-metals. We're going to look at another one. We're going to look at HCl. So I'm just going to draw the 2, because I know hydrogen's a non-metal and chlorine is a non-metal. Straight away, I'm just going to draw those outer shells overlapping. And then I'm going to work out how many electrons I need to draw in the center. I've already seen that chlorine is in group 7. Therefore, I know it wants to gain 1 electron. Therefore, I know it will share 1 electron. So for chlorine, I'm going to draw 1 cross there in the center. And I'm going to draw the other 6 crosses on the outside, just like as I had above. For hydrogen, it's not in any of the main groups, but I know it has only got 1 electron in total. Its electron is in the first shell. The first shell can hold 2 electrons. So if it's got 1 and it wants 2, then hydrogen wants to gain 1 electron, just like chlorine. If it wants to gain 1, it will share 1. So just like chlorine, hydrogen is going to share 1 electron. But hydrogen doesn't have any other electrons. It's only got 1 and it's choosing to share it. So that you're not going to draw any electrons on the outside for hydrogen. And this here is now called a HCl, and it is called a molecule. And again, you can see you've got a shared pair of electrons between hydrogen and chlorine. So you've got a covalent bond between hydrogen and chlorine. If we look at another example, this time I'm going to do a slightly larger molecule. I'm going to do CH4. So instead of just having 2 atoms, I've now got 5. I've got 1 carbon and I've got 4 hydrogens. When you're drawing something like this, the atom that you've only got 1 of, you're going to put in the center. So I'm going to put carbon in the center, and I'm going to draw its electron shell, just its outer shell. And I'm going to draw 4 hydrogens around carbon. Because they're going to be sharing electrons, because they're non-metals, I'm going to draw those hydrogen outer shells overlapping with carbon. Now notice that the hydrogen outer shell overlaps with the carbon outer shell, but the hydrogen shells do not overlap with each other. Hydrogen are not forming a bond with each other, so those hydrogen shells should not be overlapping with each other. So if we have a look at carbon, carbon is in group 4. That means it's got 4 electrons in its outer shell. It wants to have 8. If it has 4 and it wants 8, it needs to gain 4 more. If it wants to gain 4, it's going to share 4. And unlike the 2 previous examples, I don't just have 1 shared area. I have got 1, 2, 3, 4 shared areas. Carbon wants to share 4 electrons. There are 4 shared areas. It's going to put 1 electron into each shared area. And I'm going to use dots to represent carbon's electrons. I'm going to put 1 dot in each of those 4 shared spaces. There are no other electrons to draw for carbon. Hydrogen, as we've seen on the previous page, only has 1 electron. It wants to have 2, which means it will share the electron that it has. So this hydrogen is going to share its electron with carbon. This hydrogen is going to share. This hydrogen is going to share. And this hydrogen is going to share. And what you'll see is that each hydrogen ends up with 2 electrons in their outer shell, which is a full first shell. And carbon ends up with 2, 4, 6, 8. So carbon ends up with a full outer shell. And this would be called a CH4 molecule. And if I want to draw this underneath, I can draw it out like this. And it clearly shows me that I've got 4 covalent bonds between carbon and hydrogen. So that's CH4. I'm going to do another one. I'm going to do NH3. So something similar. I've got nitrogen and I've got 3 hydrogens. So again, I've only got 1 nitrogen. So I'm going to put nitrogen in the center. And I'm going to put 3 hydrogens around nitrogen. 1, 2, 3. Nitrogen is in group 5. It's in group 5. It's got 5 electrons in its outer shell. It wants to have 8, which means nitrogen will gain 3 electrons. And if it wants to gain 3, then it will share 3. So it has 3 electrons to share, and you can see that there are 3 sharing spaces, which means nitrogen is going to go 1, 2, 3. It's going to share 3 electrons. But remember, it is in group 5. It's only sharing 3 electrons. It means it does have 2 electrons left that it is not going to share. And you can draw those electrons anywhere. I'm going to draw them up here at the top, but you just need to draw those 2 extra electrons outside of the sharing spaces. So there's nitrogen's 5 electrons, 3 being shared, 2 not being shared. Hydrogen, as we've already seen before, has got 1 electron. It wants to share it, so each hydrogen is going to share its electron with nitrogen. Nitrogen ends up with 2, 4, 6, 8, a full outer shell. Each hydrogen has 2 electrons, which is a full outer shell. And this is an NH3 molecule. Again, when all of these atoms covalently bond, we say it's called an NH3 molecule. It's a nitrogen with 3 bonds around it. We'll have a look at another one. So I'm going to do H2O. Again, I'm going to put the oxygen in the center because I've only got 1 oxygen. And I'm going to put a hydrogen on either side. Oxygen is in group 6. It's got 6 electrons. It wants to have 8, which means oxygen is going to gain 2 electrons. If it's going to gain 2, then it is willing to share 2. It's willing to share 2. There are 2 sharing spaces. It's going to share 1 here and 1 here. Remember, it's got 6 in total. It's only sharing 2. That means it's got 4 electrons left that it is not sharing, that I'm going to draw on the outside here. Hydrogen, as we've seen before, is going to share 1 electron. That leaves oxygen with 2, 4, 6, 8. Hydrogen's got 2. Everyone's got a full outer shell, so everyone is happy. I'm just going to give you a few to try for yourself. So have a go at drawing F2. Have a go at drawing HF. Have a go at drawing CF4. And have a go at drawing PH3. So press pause and practice doing those 4 dot cross diagrams for yourself. So I've done the answers here. This is F2. It looks the same as Cl2. You should have 2 electrons here in the center, 6 crosses, 6 dots. HF, 2 electrons in the center, 6 crosses or 6 dots for fluorine. You should have nothing on the outside for hydrogen. CF4, each fluorine should have 6 electrons on the outside, and then you've got 2, 4, 6, 8 electrons that are being shared in 4 pairs in the center. Phosphorus, you should have no electrons on the outside for any hydrogen. You have your 3 sharing pairs, and phosphorus will have an extra 2 electrons that it is not sharing. So if we look at all of the kind of molecules that we've drawn, there are certain trends that we can spot based on the group that they are in. So you'll see that if your element is in group 4, they've got 4 electrons in their outer shell. They need another 4 to have a full outer shell. So they're going to form 4 bonds. So we've seen carbon a couple of times, and carbon has always formed 4 bonds. In group 5, 5 electrons in their outer shell. They need another 3 to have 8. So they form 3 bonds. So we've got phosphorus here, which is in group 5. It formed 3 bonds. Nitrogen did the same. Group 6, 6 electrons in the outer shell. Another 2 electrons needed, so they form 2 bonds. So oxygen is in group 6, and you've got H2O. Oxygen's forming 2 bonds to get those 2 extra electrons. And then group 7, they only need 1 more electron, so they only need to form 1 bond. And you'll see here that each fluorine atom is only forming 1 bond. And again here, each fluorine only forming 1 bond. And you've got hydrogen with 1 electron in its outer shell, needing another electron, so only forming 1 bond. Again, hydrogen's only got 1 electron, so can only form 1 bond. In all of the covalent bonds that we've seen so far, we've just had 1 pair of shared electrons, but you can have more than 1 pair of shared electrons. And I'm going to show you an example where that happens. So if we draw out O2, which is just 2 oxygen atoms bonded together. So I'm going to draw my outer shells overlapping. And we've seen already that oxygen is in group 6. If it's in group 6, it's got 6 electrons in its outer shell. It wants to have 8, so it needs to gain 2. So it will share 2. Oxygen here wants to share 2 electrons, but you can see that you've only got 1 sharing space, and that means that your oxygen atom needs to put 2 electrons into the same sharing space. It will then put the other 4 electrons, it's got 6 in total, on the outside. The other oxygen is going to do exactly the same. It wants to gain 2, so it will share 2. It puts 2 electrons in the sharing space. The other 4 electrons it keeps to itself. And instead of having just 2 electrons in the shared space, we've now got 4. That's absolutely fine. If you remember your definition for a covalent bond, it is a shared pair of electrons. As long as you've got an even number of electrons in your shared space, you're able to group them in pairs. And what this would look like if I drew it out was, instead of having just 1 covalent bond between the 2 oxygen atoms, I would have 2, and it's called a double bond. So you've got a double bond between the 2 oxygen atoms, okay? And the reason that you need to form 2 covalent bonds between oxygen atoms is because each oxygen needs to share 2 electrons. So we've seen up here, if we look at our chart, if it's in group 6, it needs 2 electrons, so it has to form 2 bonds. If you've only got 2 oxygen atoms, then oxygen have to form 2 bonds with each other. We'll see something similar if we draw out nitrogen, which is N2. So I'm going to draw 2 nitrogen atoms overlapping. So their outer shells are overlapping. Nitrogen is in group 5. If it's in group 5, it needs to gain 3 electrons. And if it needs to gain 3, it will share 3. So it wants to share 3 electrons. There's only one sharing space, so it's going to be 1, 2, 3. All 3 electrons in the same sharing space. But it's in group 5. Therefore, it's got 5 electrons in total. I'm only sharing 3. The other 2 go on the outside. This nitrogen is going to do the same. 1, 2, and 3. And then the other 2 electrons are on the outside. I've got 3 pairs of electrons between the 2 nitrogen atoms. That means I've got 3 covalent bonds between the 2 nitrogen atoms, and it's going to be a triple bond. It will look like that. Have a go at just drawing CO2 for yourself. Okay, so you're going to put carbon in the center and oxygen on either side. Actually, I'll start it off for you. You're going to put carbon in the center. You'll have an oxygen on either side. See if you can fill in the dots and crosses. Remember, carbon needs to share 4 electrons in total. Each oxygen needs to share 2. Have a go and see if you can draw that for yourself. Okay, so this is what your CO2 molecule should look like. Carbon's got 4 electrons, so it wants to share 4. So I've drawn carbon's electrons as crosses, and I've put 2 electrons in one shared space and 2 electrons in another. Each oxygen wants to share 2, so this oxygen shares 2 electrons with the carbon, keeps its other 4 to itself. This oxygen does exactly the same thing. And what you'll end up with is carbon double bonded to oxygen and then double bonded to oxygen, okay? Remember, carbon's in group 4. It's going to form 4 bonds, 1, 2, 3, 4. Each oxygen is in group 6. They want to form 2 bonds, and each oxygen here is forming 2 bonds. So the goal is to end up with a full outer shell, and by drawing your bonds this way, each atom ends up with a full outer